Hi everyone, welcome to the revision video part 3 of coordinate and conic. So let's start with question 11. The value of lambda so that 3x square plus 7xy plus lambda y square plus 5x plus 5y plus 2 equals to 0 represents a pair of straight lines. So we have studied one condition for pair of straight lines. So that is in the determinant format. So first of all, let's write the general 2-degree equation. Okay. So we have ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So this is the general 2-degree equation. And if this equation has to satisfy, it has to represent a pair of straight line. In that case, we have to satisfy a determinant. What that determinant is, a, b, c as the diagonal element and hgf as the symmetric elements over there. Okay. So now this determinant has to be 0. And if this determinant comes out to be 0, that means this 2-degree equation represents a pair of straight lines. In this case, we have one variable over here and all the other constants are known. So basically we know a, we know h, we don't know b. B is actually lambda over here. We know g, we know f, we know c. So we know all the variables. You can just plug in the value in the determinant and you can find out the value of lambda, right? Now let's look at question number 12. The point of intersection of lines represented by 3x square plus 10xy plus 8y square plus 14x plus 22y plus 15 equals to 0. So this particular question has two methods to solve it. So I'll discuss both of them. So the first method is the simplest one. So basically if you want to find out the point of intersection of lines, we have to find out two lines from here. So the first method is to partially differentiate it in terms of x with respect to x and with respect to y, and you will get the two lines. So basically you'll have to do del, let's say this expression is fx. You'll have to do del, not fx, fxy, del fxy divided by del x and del fxy del y, right? You have to calculate both of these expressions. You'll find out one linear equation from here, one linear equation from here in terms of x and y, and both of them are actually two straight lines representing these, the components of straight lines representing these pair of straight lines, right? And then you can find out the point of intersection. Now the other method is basically, we know that when we write ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So this is our general pair of straight line equation. Now we know that m1 plus m2 equals to minus 2h by b and m1 m2 equals to a by b, right? So with the help of these two equations, from by comparing this and this, we can find out the value of h and b and a and b, right? So b basically we'll be able to get m1 and m2 from here. Now we know m1 and m2, so we can write this as y equals to m1x plus c, and the other equation would be y equals to m2x plus c. Now we'll multiply both of them and compare the product with this equation, with this given equation, and find out the value of c1 and c2. Okay. So again, in this method, you'll have to go a little longer. The partial derivative method is quite easier. Okay. Now let's look at question 13. The equation of diagonals of the square formed by the pair of straight lines 3x square plus 8xy minus 3y square equals to 0 and 3x square plus 8xy minus 3y square plus 2x minus 4y minus 1 equals to 0. Okay. So the first equation is the homogeneous equation. The second one is not. But we know that we can actually factorize this one. So 3x square plus 9xy minus xy minus 3y square. So this gives us 3x is common, x plus 3y and minus 1 minus y actually. This is 3y square minus y, x plus 3y equals to 0. So we have got 3x minus y and x plus 3y as the two equations which are passing through the origin, right? These are passing through origin. One is like this one, the other one would be like this one. Now we know that the other two lines can be found out easily because those must be parallel to this and this, right? So they have just one component of constant over there, and we can actually find out that. So let's say the other two lines are 3x minus y plus c1, and second line would be x plus 3y plus C2. So this is the pair of lines which is given by 3x square plus 8xy minus 3y square plus 2x minus 4y minus 1. Okay, so this component was exactly same as this one because both the lines are actually parallel. The additional component is this one, 2x minus 4y minus 1. 2x minus 4y minus 1. So we can compare it with after opening this one. So we can get the x term from 3x into C2 and C1 into x. So 3x into C2 plus 3 plus C1 into x equals to 2x basically. We have to just compare the coefficients. So 3 into C2 plus C1 equals to 2. This is after comparing the coefficient of x, and if we compare the coefficients of y, that would be minus 4, that should be equals to, we have C2 into minus y1, that is minus C2, and we have 3 into C1 plus 3C1 equals to minus 4. Now if I multiply 3 over here, I'll be getting minus 3C2 plus 9C1 equals to minus 12. Okay. If I add this and this, this gets cancelled out. So we are getting 10C1 equals to minus 10, C1 equals to minus 1. Similarly, if you put this value over here, you'll get C2 equals to 1, right? Now we have got the equations 3x minus y plus minus 1, and the other equation would be x plus 3y plus 1. Now the basic method would be to find out the basically find out the point of intersection of these two lines, and basically find out the intersect. We have got 4 lines and we can find out all the intersection points, and then we can find out the value of diagonals. Now let's look at question number 14. The area of triangle formed by the lines 18x square minus 9xy plus y square equals to 0 and the line y equals to 9. So that's again a very simple problem. You just have to factorize this one. How to factorize this one? We'll be getting 18x square minus 6xy minus 3xy plus y square equals to 0, right? So basically we are getting 6x as common, 3x minus y and minus y, 3x minus y equals to 0. So 6x minus y and 3x minus y. So basically we have got y equals to 6x and y equals to 3x and a line y equals to 9. I think we have done this question even in the area of area under the curve type of questions. We have done this kind of question that this is y equals to 6x, this is y equals to 3x, and this line is passing through y equals to 9 passing through this cutting through here, and we have to find out this area, right? So that's a very simple problem. Now let's look at question number 15. The equation of the lines which are passing through the origin and which are perpendicular to a pair of straight lines, x square minus 3xy plus 2y square equals to 0. So over here, we can again factorize it because it's a homogeneous equation. We can again factorize it. X square minus 2xy minus xy plus 2y square equals to 0. So this gives me x minus 2y and x minus y equals to 0. So these are the two lines. Over here slope is actually 1 by 2 and here slope is 1. So the perpendicular line would be having slope minus 2 and minus 1. So you can easily write y plus 2x multiplied by y plus x equals to 0. So this should be my equation. That comes out y square plus 3x y plus x square plus 2x square. So C looks correct. Now let's look at question number 17. The length of chord cut off by y equals to 2x plus 1 from the circle x square plus y square equals to 2. Basically, we have a circle over here, right? And its center is at 0, 0 because it's a standard circle. And we know that radius is root 2 over here. Now we have to find out this length of chord. Okay. So how to do it? So we know this radius, that is root 2. We can draw perpendicular from this point onto this line. This line is y minus 2x minus 1, and we can find out this distance, and this is also perpendicular. So basically we can find out this length, and this length would be the half of this chord, right? Because we can do the same for this side as well. So this length and this length would be actually equal. Basically we have to apply Pythagoras over here. So if we find out this perpendicular distance, then that would be 0 minus 2 times 0 minus 1 divided by under root a square plus b square, that would be 5 modulus of it. So the distance came out to be 1 by root 5. So this actually came out to be 1 by root 5. Now this would be root 2 square minus 1 by root 5 whole square. and under root of it, right? And we have to find twice of that, so multiplied by 2. Okay, overall. So this actually becomes this becomes 2 minus 1 by 5, that becomes 9 by root 5. 3 by root 5 into 2, that is 6 by root 5. So this is the length of chord. Okay, C looks the correct. Now let's solve question number 18. The coordinates of the midpoint of the chord 2x minus 5y plus 18 cut off by circle this. Again, we have a similar kind of situation over here, and this is our circle with center at 3 comma minus 1, right? And we have this line going over here, that is 2x minus 5y plus 18 equals to 0. So basically we have to drop one perpendicular and find out these coordinates x and y. Basically we have to find out the foot of these perpendiculars, so we'll be using that formula. X minus x1 is 3 over here divided by a, that is coefficient of x-axis in this line, that is equals to y minus y1, that is minus of minus 1 divided by minus 5, and that should be equals to minus times, if I plug this point over here, that would give me 2 into 3 plus 5 into 1 plus 18 divided by under root a square plus b square, that would be 4 plus 25, that is root 29, not root 29, just a square plus b square. So this is 6 plus 5 11, 11 plus 18 29, so this cancels off, this becomes minus 1. So we've got x minus 3 by 2 equals to minus 1. That gives me x equals to 1 over here, and y plus 1 equals to 5. Y plus 1 equals to 5. So y equals to 4 over here. So we've got A as the correct answer. Now let's look at question number 19. The locus of the point such that tangents drawn from it to the circle x square plus y square minus 6x minus 8y are perpendicular to each other. So basically we're talking about director circle over here. So this is our circle, and we have to find out the locus of all those points from where we drop the perpendiculars, not perpendiculars, from where we drop the tangents are actually perpendicular to each other. So we can find out all these points like this. So we studied the concept that the director circle is having the exactly same equation, but the difference is only in the radius part. So the radius is root 2 times of the radius of this circle. Okay. So in this circle, radius is actually under root g square plus x square minus c. But over here we have g as 3, f as 4. So this becomes 3 square plus 4 square, c is 0 over here, so that becomes 5. So this radius is actually 5. So this radius would be root 2 times 5. Okay. Now the equation becomes simple. X minus 3 whole square plus y minus 4 whole square equals to root 2 into 5 whole square. So this is my circle or locus, whatever you call it. Now let's look at question number 20. The lines 3x minus 4y plus lambda equals to 0 and 6x minus 8y plus mu equals to 0 are tangents to the same circle. The radius of the circle is. Now, whenever we try to draw two tangents, the first thought process that comes to our usual mind is we draw something of this sort. Okay, this is one tangent and this is another tangent. But if you want to draw this kind of figure for this one, then you should be knowing center to find out the radius of this circle, right? We know this equation, but also in terms of some variable, right? We are not having the entire equation, and also we don't know the center. So how to find out the radius? So we have to look at it carefully, that this line and this line are actually parallel to each other. So this diagram is entirely incorrect. We'll have to form a diagram like this one. So this is like this, and this is also going like this. Now we know that the distance between two parallel lines is c1 minus c2 divided by under root a square plus b square modulus. Okay. So c1, c2 are and for that the coefficient should match over here. So we have to write 3x minus 4y plus mu by 2 equals to 0. Okay. Or you can just multiply 2 over here, whatever way you prefer. So let's do the other way. Let's multiply 2 over here. That becomes 6x minus 8y plus 2 lambda equals to 0. Now the c1 is 2 lambda minus mu divided by under root a square plus b square. That would be 6 square plus 8 square, right? 6 square plus 8 square and modulus of it. Okay. So this comes out to be the distance between two parallel lines, right? And that is actually diameter. We have to find out the radius. Radius is half of it. So basically you'll be getting 2 lambda minus mu divided by this is 10. So 10 into 2, that is 20. So this is our correct answer. So I think A is the correct answer. So this video was till here only, and in the next video we'll be talking about problem number 21 to 30 or maybe 35. Okay. So let's meet tomorrow. Thanks for watching.